Namaste and a very warm welcome, my dear aspiring Java developers. Today, we are embarking on an exciting journey into the world of Java Enterprise Edition Java Message Service, or Java EE JMS. This is a fundamental technology for building robust, scalable, and distributed enterprise applications. In this 5-minute animated whiteboard tutorial, we will demystify Java EE JMS, understand its core components, explore messaging models, and even see a practical code example. By the end of this session, you will have a solid foundational understanding of how to use JMS for asynchronous communication in your Java applications. Get ready to learn how messages flow seamlessly between different parts of your system, making your applications more resilient and efficient. Let's dive right in and unlock the power of message-driven architectures together. Alright, let's start with the basics. What exactly is Java Message Service? Think of Java EE JMS as a standard application programming interface, or API, provided by Java EE that allows Java applications to create, send, receive, and read messages. It's like a sophisticated postal service for your application components. The beauty of JMS lies in its ability to enable asynchronous communication. This means different parts of your application, or even entirely separate applications, can communicate without needing to be available at the exact same time. This decoupling is incredibly powerful, improving reliability and scalability. We will learn about message producers, message consumers, and different types of destinations. JMS is a crucial part of building modern, distributed enterprise systems, ensuring that messages are delivered reliably, even if a part of the system is temporarily offline. It provides a common way for Java programs to interact with message-oriented middleware, or MOM, systems. Now, let's understand the core architecture of JMS, which relies heavily on the concept of message-oriented middleware. Imagine a post office in your application. You have a sender, a receiver, and the post office itself facilitating the delivery. In JMS terms, a message producer is like the sender. It creates and sends messages. A message consumer is the receiver, interested in getting these messages. And the JMS provider, which is part of the message-oriented middleware, acts as that intelligent post office, handling the routing and delivery. Messages are sent to a destination, which is a virtual address managed by the JMS provider. We will see how to obtain a connection factory, which is our starting point to connect to the JMS provider. This factory creates connections, which in turn create sessions, allowing us to interact with destinations. It's a structured way to ensure smooth message flow. JMS offers two primary messaging models, each designed for different communication patterns. First, we have the point-to-point messaging model, which uses queues. Think of a queue as a waiting line. When a message producer sends a message to a queue, only one message consumer will receive and process that message. Even if multiple consumers are listening, only one gets it. This is perfect for task distribution, like processing orders where each order needs to be handled exactly once. Second, we have the publish-subscribe messaging model, which uses topics. A topic is like a broadcast channel. When a message producer, now called a publisher, sends a message to a topic, all active message consumers, known as subscribers, who are listening to that topic will receive a copy of the message. This is ideal for scenarios like news feeds or stock price updates, where multiple parties need the same information simultaneously. Choosing between a queue and a topic depends entirely on your application's specific needs for message delivery semantics. Let's put this knowledge into practice with a simple example of sending a message to a queue. Here, we are demonstrating how to create a text message and send it. First, we obtain a connection factory and then establish a connection to the JMS provider. From this connection, we create a session, which is a single-threaded context for producing and consuming messages. Within the session, we look up our queue destination. Then, we create a message producer linked to this queue. Finally, we create a text message and use the producer to send it. Notice how we wrap everything in a try with resources statement to ensure that all JMS resources like the connection and session are properly closed, even if errors occur. This is a crucial best practice for resource management in Java Enterprise Edition applications. This example provides a foundational understanding, and real-world applications often integrate with an application server like Wildfly or Glassfish for managing these resources. As you begin your journey with JMS, it's common to encounter a few pitfalls. One common mistake is not properly closing JMS resources like connection, session, and message producer. This can lead to resource leaks and performance issues. Always use try with resources or ensure close is called in a finally block. Another mistake is choosing the wrong messaging model, using a topic when you need one-to-one delivery or vice versa. Always analyze your application's delivery requirements carefully. For best practices, always handle exceptions robustly, consider using transacted sessions for atomic operations, and leverage JNDI Java naming and directory interface for looking up administered objects like connection factories and destinations. This makes your code more flexible and easier to configure in different environments. Following these guidelines will help you build robust and reliable message-driven applications.